So my goal here is to find the pressure felt at the bottom of the bottom of the ocean. That's 1,100 meters deep, and the density of seawater being 1,025 kilograms per cubic meter. So if I look at this, the pressure at the bottom is equal to the pressure of everything above. So I have two objects above it. The first object I have is just the depth of the water, and the second object is going to be the atmospheric pressure. So that's going to be 100,000 for the atmospheric pressure, and of course 1,100 for the meters. 1,100 meters for the depth, sorry. If I look at it in terms of my givens, I've got the atmospheric pressure at 1 atmosphere. It's 100,000 pascals. I know the height is 11,000 meters, and the density of the seawater at 1,025 kilograms per cubic meter. So the pressure I feel at the bottom is equal to the sum of the pressure of everything above me. That's going to be the pressure at the bottom, 1,100, is equal to the atmospheric pressure, because that's above me, and the rho GH due to the water, since that's above me. So this is a nice, easy problem to put in. Just put straightforward, plug in the numbers, and I get a pretty big number for the pressure. But the question says, what is the answer in terms of atmospheres? So I need to take this number and convert it over to atmospheres. So I'm going to take this 110 million pascals and divide it by 100,000 pascals. And that's going to give me 1,106 atmospheres of pressure. Now, on to part B. So for part B, if I've got a submarine at this depth and it's got a window of exactly 30 centimeters, a radius of exactly 30 centimeters, which is pretty big, then how much force would be exerted on the submarine? Assuming the pressure inside the submarine is 1 atmosphere, because it starts off with the surface of the ocean where it's 1 atmosphere and brings that pressure down. So what I'm looking at is pressure on the outside of the window at 1,100 meters, which I just found in part A, the pressure inside of 1 atmosphere, and I'm looking for the gauge pressure. So given the pressure inside is 100,000, the pressure outside is 110 million, find the difference in pressure, which isn't a really big difference, but that's the gauge pressure. So the force is equal to the gauge pressure times the area. That's going to be the pressure outside minus pressure inside times the area. So when I put in all my numbers, I get the force to be pretty big at 31,241,725 newtons.